In this video, I wanted to talk about Gleam programming language, Kotlin programming language, and pipeline programming and advent of code. So as you might know, each year in December, there is a advent of code event for programmers where programmers are presented with some amount of tasks, coding tasks, like small programs that needs to be solved, and the output should match the same as predefined output of this task. So basically you are given some input, for example, like this. As you can see, you might be given some input in form of lines of basically this input can be very large, but for different problems you get different input, and yeah, it's just a string. You can then just split by line breaks in order to receive each individual line and then process it. So for the first task I received such an input. Basically advent of code gave me this input, but for different users we have different input. It means if you look into the site, then get your input for day one, you will receive different input other than me. And that means basically if we wrote the same program, like for example, if we wrote the same Kotlin program and input here, we can do the same, and basically input will be different, and for the same program output will be also different. So I think it's just done so that people not just reuse the output of other programmers and came up with their solutions, something like that. Yeah, and in this video I wanted to talk about specifically day one. You can read, but there is a lot of text actually. So we have part 1 and part 2. I solved both. Today we'll be speaking about part 1 of day 1. The description might be not like it contains a lot of gibberish. So basically you can just copy and put it into LLM so that it give you the task without gibberish. Because on advent of code we have these stories, some words that like sentences that doesn't really matter, and in order to basically for solving the task we just need to somehow extract the most important parts, at least how it so that the description of the task looks like more like a lead code questions, because on lead code questions it's really formal and each sentence matters, but here is just story like gibberish about Christmas and elves and other stuff. Yeah, basically if so this the whole description can be summarized as that you get this input consists of lines, and air basically means that we rotate the dial to the right and left is to the left, and then for each of the line we have a mount. For example, this means that we need to rotate left on 20 points, and here rotate right to 22 points. Basically we should process line by line, rotate in our code something, and then just compute the final result. Basically, actually no, we rotating and we capturing each state we rotate this one, we look if this rotation got to 0. Right now it's 22. Then rotate 26, it is like 48. Then 68, 88, right? No, this is actually left. So basically we're rotating right, then left, then right. And on each step we're just looking into whether this rotation end up on position 0. So we kind of add, subtract, add, subtract, add, subtract, and yeah, basically we're rotating, but rotation should not overflow the 100. It means that if we on minus 100, or maybe we rotate it so that the position is minus 101, it means that we need to abrupt this 100 and just get it like 1, because we have dial, which is kind of the circle which we rotate, and it only has 100 positions. Okay, you can go to other YouTubers and maybe to LLM so that it describes you better. But the point of this video is the solution itself. I pick 2 languages which I like. So first is Kotlin and the second is Gleam. And the code looks like pretty much similar. So if you know Kotlin, you kind of can transform some things from Kotlin right into the Gleam. And the good part is that both languages kind of support this declarative or pipeline programming-like thing. Basically, programming style, code characteristic, and philosophy. This is I wrote in my GitHub. So both these languages support pipeline programming. Pipeline programming means that we describe what we want right in the program. So we kind of describing the process step by step, which is really readable. So as you can see, for example, in function main, and here we also in Gleam we have function main. Just syntax a bit different, but code does exactly the same. So if you look yeah, let's talk about the pipeline programming, of course. So we got this input holds exactly these lines of input like this, and then we just trimming and then transform it into lines. At this point Kotlin returns a sequence or something like that of lines, so it automatically understands that that these are lines, and it automatically breaks. So this is the first line, second line, and so on and so forth. So it produces automatically sequence of these lines. Here at this point. And in Gleam we doing the same. Basically we have this input, but in Gleam we string split, so we explicitly split by this line break symbol, but in Kotlin it's kind of implicit and encapsulated in the standard library of the Kotlin, but in Gleam we specify explicitly. So here is a good point for Gleam. It's forcing us to be explicit, but in Kotlin it is more concise and more like user-friendly. I mean, maybe person from business, if he comes and see the code, then of course this lines is much more understandable, because he would understand that we from input we get lines and that's it. So in Gleam it's more technical. So yeah, pipeline programming, first step, trim ident. In Gleam we do not do this, but we also can trim ident. Then we have lines, then mapping to string, to also trimming each of the line. Why? Because here, as you can see, here we have extra space. It's just because the advent of code gave such a input that some lines can contain this extra space. Basically, maybe all of the lines contain, basically all of the lines. So we absolutely need to trim to remove this extra space. So in Kotlin, it's done like this. We mapping string to trim. It's basically, I think, the same as in Java, but in Gleam, we using the module called list, and then map string trim. So basically, what it does is that how to understand, right? Gleam, the Gleam program. So we retrieve this input, and this pipe operator is kind of means that we take everything to the left, the expression from the left, and we kind of put in through this operator to the first position of this method call. So in other words, if we use string split, then the split has two parameters actually. The string, the input itself, and then the character, the separator by which we need to split the string. So yeah, it is kind of seems not really usual for programmers who came from Java or other languages. But if you understand what's happening just once, then you understand basically the same principle everywhere in Gleam programs. If we use this pipeline operator or pipe operator, then you understand what it does. So yeah, we kind of put in here, calling this function, then it returns the expression, the result, the value. So basically this is expression. We also use this pipe operator to put it into the first position, then compute this expression, then of course again we put it in here. So this list filter has two actually parameters, the expression, this one, and then the function, the predicate by which we are filtering. Then of course we computing this expression, put it into calculate password function. So this is the function, like kind of function reference. It also means this calculate password also has one parameter. Which parameter? This one. So we computing this, right, and then just using this pipe operator to put into first position, in the first parameter of this function. And this calculate password looks like this. The function, as I said, receives this list of string and does its job. When it does its job, it returns the int, and here so this calculate password returns int. Then we again piping in into int to string, and then printing. So in Gleam, we should always, we cannot just print random stuff as we do in Java or Kotlin. We absolutely need to first cast, or not cast, but coerce to string before we can print into this print line. But in Kotlin, so this is the analog of Kotlin. Kotlin does not have this pipe operator like this in Gleam, but nothing prevents us in Kotlin also use this programming style called pipeline programming, where we computing first, then second, like describing the algorithm step by step. The good part is that some of the for example, sequences or list, it natively supports this map operation. and filter operation. But if then we need do not need to process each element from the sequence, but we need to operate on the sequence itself. We can just use this scope functions like let to pass the function reference, calculate password here, and then let print line. So using these scope functions from Kotlin, we can simulate the pipe operator from Gleam, and other programming languages like OCaml also has an F#, and in .NET, in C#, we kind of can also declare the pipe operator, but only one symbol. And PHP also, they now have this pipe operator in PHP as well. So here you go in pipe in PHP version 8.5 we have pipe operator now, so we can do like that. Exactly this, like the operator looks the same as in Gleam. In Gleam it was from the start of the language, but in PHP they added this operator. You can see, just to support pipeline programming. So that's pretty much it, how to use pipeline programming in Kotlin and Gleam. And then just to talk about the algorithm itself, so we just receiving this input, parse move delta, basically passing in the function reference here, then scan. So the scan function, it's like fold, but on each step it just yields the current result of this closure of this function call. Basically what it does is, when we're retrieving this input, we map into parse move delta, and then for each element within this list we just so this function is called, and each result of this function here, it's kind of remembered, and then we just count in the zeros. So basically each time we computing, and if this computation leads to 0, then this function counts all of the zeros outcomes of processing. And here parse move delta, we just calling it here, as I said, it just given the line. Yeah, this variable should be called as line, not just text. But what we do is we text drop 1, it means that we get in the first element and then transforming it to int. And then depending on the first position of this line, if it is left, then we take negative amount. If it's right, we just take positive amount, or else we just panic, we just throw exception. Here. And also the same approach is done in Gleams. This parse move delta is, as you can see, we're doing absolutely the same, but for when we are taking the first element, basically this is the input, right? So this is the first element, like kind of the direction. It can be either right or left, and in this input we are receiving all of the input as right or left, and then the amount on which we need to rotate. So all of the rights will be positive, like positive 22, positive 26, but if it's left, it's just negative 20. But if we encounter in input some bad position, but of course advent of code does not have anything other than left or right, so our program is safe. So here we just do panic. So panic in Gleam is can be thought as a unhandled exception, unhandled runtime exception that we should not recover from. So this is the exactly like the unrecoverable situation. It means that something went absolutely wrong and we need to see this error, we need to see the crash of our application so that the fix. So it means that, for example, here it means that advent of code kind of not obeyed the contract. The contract was violated by advent of code if they have in input some gibberish, not right, but some other string, not right or left, but something else. So we just panicking. So, and also this is in Gleam, this mechanism panic can be used, but also you might encounter the same kind of mechanism, but maybe implemented in other way in Rust or Go. Also there is a concept of panic, but if you come in from Java or Kotlin, it's basically the same as just throwing an exception which you do not want to handle. As you can see in Kotlin, it's much more concise to retrieve the amount, for example. So we drop in, we just skip in the first part of the input, meaning that, for example, here we just skip in R, and we just caring about the amount itself. So here we skip in, and this produces exactly like for this row it produces 22, for this one 26, and so on and so forth. So here we retrieve this amount, and then again we looking into this line, for example this one line, and again this function, just to note, just to highlight it, here it receives exactly one line. So for example this one or this one or this one by one. So if we consider this one, then amount will be 22, this variable or constant 22, but text first, it returns the direction itself, whether it's left or right or contract violated, and we just throw in unhandled exception. So it's really concise, and in Gleam we just using just basically the same logic, but just the syntax is different. We take in this line, then drop start. So in Gleam we using a string. String is just module in which we have some useful functions for strings, for variables of this type. So in Gleam module string we also have this function drop start, meaning that we do not just throw it away, we just drop in this first position, first grapheme, like this. And then, for example, here if we drop, we left with the amount itself, with the number itself. So in Gleam it's just string drop start, but in Kotlin it's just drop on the string itself. I do not remember on Kotlin we have extension function or something like that, or this is the drop function is member of the string. It does not really matter, but the syntax is that. But in Gleam we just do in text and then pipe operator and like this. We can do not use pipe operator, explicitly put text as a first parameter, but just for readability and For pipeline programming approach, I just use like this. Then when we drop in, we parse into int. So here also we're doing parsing in Kotlin, but in Gleam it looks like this, int parse, and this int parse, it returns a result. Result, you can think of result as in Rust we have also result that we need, that has like undetermined, like from the code perspective, right? When we receive result here, we should to decide if it is some value or it is error. But in Kotlin we do not do this, meaning that if we drop in and this number is not it's not number, then this toInt will also kind of panic, it will throw an exception, and entire application will crash here. But in Gleam, when we do int parse, it kind of it returns the result, and kind of Gleam forces us to deal with this result. We cannot just retrieve the int from parse and that's it. That's why we need to handle the case where we do not have value in result. And for this purpose, we just call in result unwrap, specifying the default value. So what it does is that, so we int parse it returns the result, and then we pass into this one function. So what it does is that if this int parse produces a result with some value, meaning that we parsed like this, so this is okay, and this is okay. But if it will like err some gibberish like this, then of course it will return not the number itself but error. And for error we need to specify the default value. So we just call in result unwrap, specify the default value. If but of course Advent of code will not produce gibberish, it just produces as is. So the contract is clear here. We will not end up in this situation using this default value. But just to mention that Gleam programming language forces us to think about all of the cases in our program, so that we logically kind of cover each and every scenario, and our program do not crash silently. But in Kotlin, it's not the case. Kotlin is less suitable for some critical systems. I think Gleam is much more suitable for critical systems because programmer just can forget about to handle that this is not actually int. But in Gleam forces us to provide default value if it's not. Of course, in Gleam we have such instruments as panic, but it should be used really carefully. Maybe in this scenario, maybe panic is not suitable. Maybe if it were like really critical system where we need to ensure that we do not have runtime surprises just because of the input is not valid. Maybe some user violated the input, then we should kind of recover. In this situation, I would not panic, but just return, for example, 0. It means we do not rotate, not left, not right, but just 0 amount. So this is not really safe and discouraged in production if you write some really critical software, for example, in financial services or something like that, when we absolutely need to ensure that the process is like must be as resilient as possible. So that was parse move delta, and then so the core algorithm when we doing this stuff is calculating password, And good part is that both languages kind of support declarative-like or functional-like programming. Of course, it's not really functional. It's just like mimicking the functional programming, but we can think of it as a declarative programming. Like again, here I describe the characteristics of the code that I want to use for this advent of code programs. So kind of functional like, declarative like, data oriented programming, pipeline programming, and yeah, you can read it as well. But the thing is that both languages support this scan function. In Kotlin, it's just on a list, available on the list itself. So providing the initial state and then providing the function. And this scan function internally, it loops through each element of this list, and yeah, and then just produces the next state, next state, next state. So you can think of it like a kind of state machine that given the previous state, so here as we retrieving the previous step and computing the next step, which turned out to be again input for the subsequent step, and so on and so forth. So we can kind of looping, but the loop itself is not. We do not write the loops like most programmers do, right? We just use here scan function, which does explicit looping for us. And the consequences is that the code is consistent and declarative. So in Gleam, we also have this scan function, which does exactly the same. Logically, we can think of it as exactly the same, but here in Kotlin, we just providing the function itself like this. But in Gleam, I just decided to provide the function reference and have this private function declared like this. In Kotlin, we also can, of course, extract this into separate function and just provide the function reference as we did here. But yeah, so that's pretty much it. So both languages support the scan. So it's really cool because the syntax, the structure is exactly the same, because both languages support this declarative style, and style actually the same, and absolutely like these languages. Yeah, so I think that Kotlin should be used for not really critical systems like e-commerce, maybe some kind of stupid stores in which you do some not really critical stuff. But I think Gleam is more suitable for some financial services or systems that should not crash in production in random places. Of course, programmers can escape this by using this, but you can just use the static analyzer for these things to reach absolutely the state where your program will not crash in random places. Because the type system, because everything in Gleam works for you, so that you produce the safest software possible. You can also read reports. So yeah, the cool stuff is that if you go to Stack Overflow Developer Survey 2025 and open up the technology section, you can see that among all of the respondents, Gleam firstly appeared at this position in 2025 in Stack Overflow Developer Survey. And if you go to the most admired and desired languages, you can see that the most Rust is definitely winner with 72%, but after that followed by Gleam 70%. So this is really cool that this language firstly appeared on Radar on 2025 by Stack Overflow developer survey, by actually respondents whoever filled in this survey, of course, and yeah, pretty much really cool results. And another one cool thing, if you go to the Gleam website for case studies here, you can also read many, basically not many, but as of now it's just 2 case studies presented here, but guys who use this in startups and their critical systems, they report that no room for error and very good maintainability of the code bases. So exactly what I say, that no room for error, that you can read it. Basically they say that there are no actually errors from the Gleam perspective from the language itself. So the language is really designed very well, that if you use it and you kind of enforce this static analyzer to prevent some dangerous stuff, then you absolutely can be sure that the program will not crash, will not panic, or in other terms, for developers who use Java, we will not throw an unhandled runtime exception that will just kill your thread because of some kind of, for example, data issue. So that's pretty much it for this video. Kotlin stays as my favorite programming language as of now, but Gleam is very close, like in terms of the beauty of the syntax and the reliability and everything. It's maybe more code to write and read, right? Maybe in some cases it just because Gleam does not have loops, maybe code will look like more redundant or something like that, or how to call that. But on the other hand, code is much more readable. Yeah, and recursion is done basically by calling some functions within the modules of the Gleam, or using recursion explicitly, and then if you use tail recursion, then it's optimized to a single, like not single but to loops under the hood, so it's efficient. So using Gleam you get the full declarativeness with optimization and under the hood. And that's pretty much it. Thanks for watching.